welcome back to A Better World. This is your host, Mitchell J. Rabin, and we're very glad you're joining us again today. We are on location in Gilroy, California at Green Ray Technologies lab, where a lot of really good things are brewing. Things in the domain of the latest and perhaps the most important kind of work that this planet needs at this point, which is the area of green technology. We are seated with the inventor, caamano, who we've actually had on the show several times before in regard to another invention of his having to do with what you could call the inner environment, the ICAP release meter. Well, today we are going to be focusing on the outer environment and the kind of work that he's been doing. After we do a little bit of a survey of the importance of the role of green technology at this point in time related to global warming, climate change, our carbon footprint. These are vitally important issues that have been skimmed over by way too many corporations and governments over the past number of years. And with the Obama administration coming into effect, there is an upsurge in interest, excitement, and money invested in this domain. And Ray and I are working to educate more and more people about this so we can make intelligent, wise choices to actually help to preserve our species. So thanks for coming on the show today, Ray.
Well, thank you for having me, Mitchell.
Absolutely. Let's first just take a little bit of a survey at what is the carbon footprint? What does it mean? What is its relevance for us on Earth at this point in time?
Well, I think many people know what carbon footprint is. It's essentially carbon emissions, and it's definitely affecting our atmosphere in a very detrimental way. And our atmosphere is a very delicate thing on a planet, and we've adopted such infrastructure and technologies that are very destructive to the atmosphere that we have. And we really need to, as rapidly as we can, take steps to eliminate the most destructive parts of the infrastructure first and move our way back to a completely zero carbon footprint, at some point, maybe 20, 30 years in the future.
But what we're looking at with the carbon footprint, Ray, is this idea of noxious emissions, quite honestly.
Right.
Carbon monoxide, excess of carbon dioxide in the atmosphere that's disproportionate with its oxygen levels and the other elements of air.
Right, right. So,
and the causes of these are?
Well, the biggest cause, I think, is the on-road traffic and the internal combustion engine. Combined in a moving vehicle, the liquid fuel is only about 15% efficient in terms of moving the vehicle and transporting the people and so forth. So the rest of
fossil fuel, gas,
well,
use of oil.
Well, not so much the ch is how we're using it.
Yes. Yes.
So if 85% of it is going off in unburned, much of it is unburned fuel, but the majority of it is heat. So we have
radiating from the motor.
Right, around an 85% heat emission through the radiator, through the transmissions, the gears, the engine itself, the exhaust system. All of this heat is unharnessed in a moving vehicle because there's no place to use the heat. The heat is just, you have to get rid of it or the internal combustion engine will overheat and destroy itself. So
right, so it has to be whisked off
instead
of possibly utilizing it.
Right.
That could happen perhaps in more domestic contexts, like with a furnace at home as an example.
Or a combined heat and power system where instead of just running a burner of natural gas to heat your home, which is fairly efficient, run what we'll call a small generator that all the heat is harnessed off of the generator, so there's an electric output as a byproduct.
Mm-hmm.
But 90%, it becomes about 90% efficient in the utilization of, let's say natural gas, which we have a tremendous infrastructure in place for natural gas. There's a natural gas line to most of the homes in California, a good majority of them.
Mm-hmm.
And just by pushing up the natural gas usage by maybe 20-30%, we could be charging a good majority of our vehicles, because electric vehicle would be in the vicinity of maybe 90% of putting all the energy you put into the battery system to work, moving people, because an electric system is far more efficient. So most people are only driving, say, a 30-mile range every day. And there, if you were to need a greater range, you would just have a small internal combustion engine driving a generator, like a hybrid, to push you further. But most people can recharge off of a natural gas generator at home that would be part of their heat system, every day, and that would be, sufficient for most people, for most families.
So in other words, Ray, even right now with current resources and current technologies, you're proposing that there could be an interim step before we get to the ultimate expression of, let's say, free energy or something like that, which is still down the road, but we know exists because the planets somehow have their orbit, as do the solar systems and the galaxies and everything else in the universe. So we know that energy, there isn't a major company that is orchestrating all of that. So we actually know that free energy exists.
Yeah.
But
Solar is free energy. And
solar is free energy and wind as well.
Yeah.
But what I'm talking about is some other fundamental force that sort of is the ticker of the universe, so to speak, the prime mover behind all moving bodies. So short of that, you're saying that currently we could set up a system utilizing natural gas as an interim step, using in a cogeneration kind of way per home.
Yes.
And also using wind, also using solar, and maybe this is a moment to bring up your wonderful new invention, which I like referring to as a cool motor, because unlike anything you've seen before, this runs cool. It is heatless, it is frictionless. And why don't you explain a little bit about what it is and the breakthrough technology that you've come up with?
Well, electric motors this is an electric motor, but with very advanced materials. Electric motors consume anywhere between 60% to 80% of all the electrical energy generated. And 98% of all the electrical generated is generated by electric generators. So it's all motor generators. They're all essentially the same device, except one is being driven by mechanical power and then turned into electrical power, and then the motor consumes electrical power and turns it into mechanical power. And that's how we move energy. And since the turn of the century, since Nikola Tesla's invention of the polyphase system, it's exactly what we've been doing, and that's what the Industrial Revolution was based on, was Tesla's inventions of the polyphase system, generators, alternating current to move the electricity long distances, and then a way to utilize it at the factory, at the home, to free mankind from work. All the work's being done by electric motors. That's why such a massive amount of energy is going into electric motors. And most people don't think about it because they quietly are moving industry forward on a daily,
moving our entire society
24/7
every day.
Yeah. These motors are running, freeing mankind from
behind
work.
the scenes, so to speak.
Now that energy is more than all the on-road traffic burns. You look at all the vehicles moving around burning fossil fuels. That amount of energy is more than all the on-road traffic burns. So what we need to do is we need to take the inefficiencies out of our entire system, and the biggest inefficiencies exist right now burning fossil fuels, to move vehicles. So what we've done here is come up with a motor that implements some of the latest breakthroughs in materials science, materials technology, because electric motors have been around for over 100 years.
Sure.
But the materials, even the materials in use today, are the exact same materials that were built
from the beginning.
From the very beginning, 100 years ago.
And it's interesting, you mentioned Tesla, and most people don't realize that Tesla is the inventor of the induction motor.
Yes.
And so between that and alternating current, his inventions actually run the 20th century industrial age.
Absolutely.
And most people actually think it's the work of Thomas Edison, whose inventions have been generating the 20th century.
Thomas Edison was an advocate of direct current, and Direct current is the system that you utilize on your automobile. You cannot transmit electricity long distances with
Right.
direct current, at
Right.
least at that time. Today, now they have high voltage DC that they transmit on the grid, but that is only as a result of being able to step the voltages up through alternating current. So without
Right.
alternating current as a foundational technology, there would never have been, the first power station in the United States was at Niagara Falls, which was funded by JP
George
Morgan.
Westinghouse.
Well, it's funded by JP Morgan, and it was Westinghouse technology it was basically Tesla. It was Tesla's technology licensed by Westinghouse. And it lit the city of Buffalo as soon as it was online, and then a year later they ran a transmission line into New York City. So that was the first, demonstration of a functional generated where there's a power source transmitted into a big city system that was extremely successful. And then that was replicated from east of the United States across to the west. And during the days of the New Deal, the 30s coming out of the Depression, massive public works